Norman, Oklahoma is home to the National Weather Center. Join us inside as we learn more about the work that's being done to better understand severe weather patterns in the United States.
The National Weather Center is a really unique confederation of federal, state, and academic units all housed in the same building, and we're working on analyzing all of the different time and space scales of our atmosphere so that we can figure out what's going on. So we have a variety of different folks that make up our building. It's actually part University of Oklahoma and part NOAA, or the National Oceanic and Atmospheric Administration. So it's a collaboration between the two groups, but this is technically a University of Oklahoma building. So we have entities on both sides in addition to entities from the state of Oklahoma as well. We have meteorologists, climatologists, we've got students, we've got faculty, staff, technicians, everyone working together to study Earth's atmosphere. We officially broke ground for the National Weather Center November of 2002, and then we opened and dedicated the building September 29th of 2006. So we're almost at 12 years operation now here at the National Weather Center in 2018. And the building didn't exist before we opened the doors back in September of 2006. Both the entities for the University of Oklahoma and NOAA were in separate buildings in different parts of Norman. And so this was a way to bring everybody together into a shared collaborative space. Right now we're standing in the atrium of the National Weather Center, and right behind me, this is really a showstopper in our building. This is Science on a Sphere. This is installed in over 100 locations across the globe, so if you go to a Natural History Museum or Science Center or other NOAA agency, you'll actually find these on display. It's a global display system. The globe itself is 6 feet in diameter, and using the 4 surrounding projectors to project a portion of the image onto the globe surface, and we stitch them together at the seams so it looks like it's one unison image. So we can bring up atmospheric products, ocean products, astronomy products. It can literally be anything you want it to be. So it can be the Death Star, it could be a fishbowl, it could be a disco ball, and it can be used for promotional purposes too. So we get a lot of usage out of this, and it really is a showstopper in our building. Right now we are inside the vehicle bay here at the National Weather Center. We're #1 in the nation in severe weather and radar research, and you get a good image of that here behind me. We have a lot of tools that we use to get our information from storms. We have right here one of our mobile mesonet displays. So we've got surface observation stations that are scattered all over the U.S. in various places. The problem is they're static, they don't move, and they're not always in the location where storms are located. And we want to figure out what's happening in all different parts of the storm. So we made those observation stations mobile by attaching them to vehicles, as you see right here. We have a hail-proof guard that's on top of the vehicle here to make sure that if we are underneath a storm that's producing some large damaging hail, it won't damage the windshield or anything here on the truck. And then we will take out these and get information inside the storms, everything from wind speed and wind direction using our anemometer there at the top, temperature and moisture measurements from our U-tube here sitting on the front, pressure measurements. We have a variety of different instruments to do all of that. There's an RF antenna and GPS on the very top so that we can communicate with everybody in our field campaign so that we know where to situate ourselves and to make sure that everybody's collecting information that they need to in those particular locations. So we have one of these here in the vehicle bay. There's one in the outside vehicle bay area too. And during larger field experiments, we will actually get additional vehicles, anywhere upward of 10 of these, so that we can do lots of observations at the surface from a variety of different storms that are happening all over the place. So these are our mobile mesonet vehicles here at the National Weather Center. The other thing that we have, we're #1 in the nation in radar research. The reason there is Doppler weather radar in the U.S. because that started here in Norman, Oklahoma with the National Severe Storms Lab. We have 159 NEXRAD Doppler weather radars all over the U.S., but the problem, again, is they are not always exactly where the storm is. If we're looking at a storm really far away, we're actually looking several tens of thousands of feet above where the actual storm is because the Earth is tilting away from that beam when we send it out. And so we got the idea to make those radars mobile. And so we have one of our shared mobile atmospheric research and teaching radars, or SMART radars. This is a joint project between the School of Meteorology here at University of Oklahoma and also the National Severe Storms Laboratory under NOAA. This is a really impressive system. We have 2 of these SMART radars, and the National Severe Storms Laboratory also has another radar that they've got parked here too. We will take these anywhere that we have the funding to do so. So we've taken them to the East Coast and the Gulf Coast to scan hurricanes when they make landfall. We've taken them, obviously, to look at severe weather here in the Central and Southern Plains. We've taken our radars to Vancouver to scan snowfall during the Olympics. We've also disassembled these radars and sent them across oceans to do a variety of different projects. So we sent one of these radars to France to do a lightning and precipitation project. And we also sent these radars to the Maldives to do tropical rainfall experiments. So anywhere that we have funding, we will take these. So they're not just locked to the ground here in the U.S. We'll take them anywhere that we've got funding to do so. And this is one of the reasons why we're so good at our severe weather research here at OU.
Radar technology was developed during the early days of World War II, primarily in England, but contributions from the United States. And the idea was to detect planes. I mean, it went on to detect missiles later, but mostly to detect planes and submarines in the early days. And weather was not something that they wanted. It was a problem because they were looking for point targets. But after the war, then it became obvious that you could detect weather, which are these distributed targets. And so the radars were modified, radars were being improved. The first weather radars came from the military, and they had been in airplanes and defense installations, and they transferred to the civilian part of the federal government. But a lot of weather radar research was done right here in Norman, Oklahoma, by the National Severe Storms Laboratory and the University of Oklahoma. And so many of the improvements, we're proud of those because we've in large part done that development. Radars send out a pulse of electromagnetic radiation, actually send out a series of pulses. Those pulses bounce off of targets. In the case of weather radar, the targets are precipitation particles. Then we get return energy back to the radar. From that return energy, we get the location, the intensity of the precipitation. With Doppler radar, then you get the velocity information, and we have something called dual polarization, where we alternate our waves horizontally and vertically. From that, we get a lot of size and types of precipitation particles. We can discriminate one particle type from another. So weather radar does all of that now. Didn't used to do all that during the time of my career. Many of those things have been added. Weather radar data now is collected in many different locations around the United States. And the primary network is the federal government network. And it's 3 agencies of the federal government: Department of Commerce, that is the National Weather Service; Department of Defense, primarily the Air Force; and Department of Transportation, the FAA. We share this NextRad radar network, the WSR-88D radars, and then those data are collected for the use of the agencies, and then they're shared with anyone who would like to get the data. Ours is a different system than other places in the world, where even the governments sell the radar data or other weather data to the public. But in our country, we don't do that. We share that data and make it available. So if you see weather radar data on television, it could be coming from one of our government radars. We have a long history with radar. We want to continue to make radars better. But where we're going now, the next big innovation, I think, that's going to provide improvements to our warning and to the forecast that we give is something we call warn-on forecast. We want to take the data from the radars and from other sensors, the mobile mesonet stations, surface stations, other kinds of data from aircraft or drones, whatever kind of data we can get. But a lot of it's driven by radar, and we want to assimilate that into high-resolution numerical models. We want to be able to run those models in real time, and we want to be able to forecast the future state of those storms, and even to the point of predicting tornadoes 30 minutes or even an hour ahead of time. So we could issue warnings with long lead time. Now, long lead time means we'll have to figure out how to treat them, because if you tell somebody a tornado's coming and it's in an hour, well, he may not take shelter right then. But there are people and groups who need long lead times, and we want to bring the public into knowledge of the weather, knowledge of the warning, and knowledge of what to do to be safe.
The stuff that we do here at the National Weather Center impacts everybody. This is a one-of-a-kind facility. This does not exist anywhere else in our galaxy. This is the only National Weather Center. We really are a tourist destination for the state of Oklahoma and for the entire country, too, in the world, because everybody's interested in weather and they want to see what's going on here in our facility.